is to learn things. Okay, most of them are freely we can learn, some are we have to pay to learn. Okay, but whatever it is, nowadays we have a lot of resources to learn. So keep learning, keep up your upgrade your technologies. Not always, guys. AL, ML only important. Not like that. Every technologies has their own recognition, own importance. Only for getting a more money, some people keep advertising only particular type of courses only. Okay. So only if you are working in a cloud, that is the greatest thing. Only if you are working in a what we can say AL, ML, if you learn, that is your greatest thing. Not like that. I know some people who are completed course in data science, they learn everything. They joining service desk because job opportunities direct to fresher job opportunities are very less. And second hand, it is the training centers, certain set training center not giving 100% information, 100% full type of skill set is not there. Okay. So there's a lot of aspects are there. I'm not talking. So I'm telling only simplest point is whenever you get a chance, keep learning. Not this particular course. This is a very good course. This is not good course. It's not like that. Based on your interest, keep learning. Okay, that will give more confidence on the subject also. Okay, yeah. No one is speaking anything. I don't know whether yeah. Yes, we discussed about system configuration and IP address, different type of IP, sorry, how to check IP address, MAC address differences, and also we discussed about DHCP, DNS, only one point only. And also we discussed three commands. One is ipconfig space slash all get MAC address and trace sorted into. So I told about a ping command. Okay, and we started networking basics. What is network, what is networking, what is internetwork, what is internetworking. Different type of networks like a LAN, CAN, MAN, WAN also we discuss. Local area network, campus area network, metropolitan area network, WAN, wide area network, intranet, internet also we discuss. And default gateway, NIC, network interface card, Ethernet, fast Ethernet, gigabit Ethernet, and also we discussed about a MAC address. Okay, again. Next, we discussed about different cables like a coaxial cable, twisted pair cable, UTP, STP cables. There's names, wires, kind of stuff, standards, and fiber optical cable. Also, we discussed. After fiber optic cable, we also discussed about a different topologies in the network. Okay. Now today we are going to discuss about networking devices first. Okay. Now we'll start the networking devices. I'll try to make it very lightweight, so at least main points, but it won't happen because I can read PPT and tell these are the points, but I cannot agree that to tell like that. Okay. Whatever we learn, that is a very smallest thing, but we have to learn very clearly. Okay. Guys, today is a 14th, 12, 2022. Okay, today topic is networking devices, hubs, repeaters, switches, bridges, routers, and modem. So the highlighted one is very important to know it. Not only these devices, guys, there is a firewalls, VPNs, IDS, IPS devices, checkpoints, for security. These are a security purpose only. Checkpoint servers are there. Okay. ASA, PIX. ASA is a firewall. Sorry, firewall means the lot of firewall devices. ASA firewall, PIX firewall. So many type of firewalls are there. DSU, DSU, DCE, DTE. These are the different type of devices are there. But so many devices are there. After that one, we'll see about a hub, routers, switches, and modems. These devices are we have a discussion. Okay. What is hub? Hub is used for LAN communication, used for small network, non-intelligent. Just I'm going to roughly I'm telling different devices. The repeaters are repeat the signal to communicate in a longer distances. Again, switches and hubs are used for LAN communication, and switch is used for a small and large networks. Switch understand MAC addresses. It can able to learn MAC addresses. Bridges are software based. It is connects between two different networks. I said important one only, right? That's why I removed that one. Okay. Modem is used to connect to ISP or used to connect internet. What is the use of modem? With modem only we can able to connect it to internet. Okay, you either using telephone cables, like internally we are using twisted pair cables, but from modem to ISP we are connecting through telephone cables or optical fiber cables or fiber optical cables. Routers route between different networks used for both LAN and WAN communications. Internetworking device it will tell how to reach destination. You open a google.com. Google.com is somewhere is located. We don't know how to reach google.com. The routers in the network, internet, will tell you how to reach the destination. It will show best path to reach the destination. So these are the main devices, guys. The highlighted one, hub, switch, router, modem. Okay. So that is a thing, but one by one explanation is there. So that is we will see from hub onwards. So initially it is hub. Hub is a device which is look like this one. It is a hub. Okay. So hub is not an intelligent device. It does not understand what is MAC address or an IP address. What is this hub will do? Hub broadcast hub broadcast to everyone means how it is happened broadcast packet to every device in the network. These drawings will kill the time. You have a device, you're connecting these devices like this. Okay, like this, I connected devices to my hub. This is my hub. This is my PCA, PCB, PCC, D, AE. I think that is enough. PCA. Okay, so what will happen? A want to communicate it to B. So A want to send a packet to B. So A to B communication. This is A to B communication. So what will happen? A send a packet to hub. Okay. Hub will send a packet to B and C and D and E and F also. Okay. Not only A, also B, C, D, E, F. So what happened? What will happen? So whenever C received a packet, check the destination, it is belongs to B, it will drop the packet. Why arrows are coming? No arrows. Okay. So remaining devices will drop the packet and this will accept the packet. This is correct. Okay. So what is the hub works like this? Guys understand hub? So here I have written what is it broadcasts the packets to every device in the network that's connected to the hub. So not only for a actual destination, also it will share to all other devices. The next one is it works in the LAN communication. It is suitable for a small networks and it is a layer 1 device. Hub is a layer 1 device as per the OS layer. As per the OS layers. So hub again for hub called as a single broadcast domain and a single collision domain. What is collision? Parallelly, packets are traveling in a same place. So look at here, guys. This is the hub. Packets are traveling like A is send a packet to B. So A send a packet to B. So it will send a B and C and D and E. So this entirely it is broadcasting. And same time C send a packet to D, and C send a packet to D, the packet go for A, B, D, E. Means all packets are traveling in a same place from all resources, all sources. What happened? Collisions will occur here heavily. So collision means a packet will be the packets will be damaged. So that is a collision domain and a broadcast domain. It is a number of collisions will occurs and packet data loss is higher. Next one, guys. This is our part. Next one is repeater. What is the repeater? The repeater repeat the signal. Okay, repeater repeat the signal. Our twisted pair cables support only 100 meters. Okay, after 100 meters, for example, here is a one device and there is another device sending a packet, but the distance is around 100 meters and it is more than 100 meters. What happened? This is 100 meters completed. What happened? Your signal become weak. What I will do? I will put one repeater here. So the repeater repeat the signal. So another 100 meters, your signal will can able to pass. So what is the use of this repeater? Repeater repeat the signal so can able to send a. Of course, you can use hub as a repeater also. But I will show you the repeater. Like this. The first one is repeater, next one is hopper. So this is the repeater. Generally we use in the networking. Nowadays, are we using these repeaters? Yes. Example, Wi-Fi extender. Your Wi-Fi extender is this kind of stuff. Use it to like for example, you are using a Wi-Fi network. You are sitting in a corner room, so your signal is weak. What to do? We use Wi-Fi extender. Of course, in Instagram and all, so they are showing some kind of mm, things like Wi-Fi extender is not required. We have to use this kind of shortcuts. But really, I don't know that is really works or not. I don't know. But Wi-Fi extender is that's so Wi-Fi will go to multiple places. Okay, not diverting into one location. So you have to follow the instructions properly. Okay,
Sir, does
so
it really work? Wi-Fi extender?
yeah, Wi-Fi extenders works. This is your Wi-Fi router.
Sir, it increases the space and we get signal far.
Right.
Yes.
Your mobile phone or laptop is your so distance is there, or more rooms are there, more partitions are there, like a glass doors kind of stuff is there. The signal may not be able to reach. So you'll get only one point or a no point kind of stuff. So what we'll do, we'll have to check properly the distance where signal is become weak and where signal is good. Okay, based on our place and weak signal. For example, at this point only one point, and this is no point. So what happened? This Wi-Fi extender what will do, take receive a signal and repeat the signal. So then it will able to we can able to get full signal. So Wi-Fi extender don't interchange or don't change anything. They will receive and send it. But originally you are connecting to your main router. Your main router is connected to internet. This is for only to pass on the signal. Okay, you can take in from Google, then try to see those pictures, so then you will understand. So for example, this is a thing. So how Wi-Fi extender works, how to place your Wi-Fi extender, where to place Wi-Fi extender kind of stuff. Okay, that is about hub and repeater. Next one is switch. What is switch? We'll see. Well, okay. So switch works with loading after the operation switch works and also there is one point. Again, hub and switches both are used in a LAN communication only. Okay, it is a layer 2 device. It is a layer 2 device as per the data link layer. Sorry, it is a layer 2 means data link layer as per the OSI. We use it for a small and large networks. Both hub and switches are star topology devices only. So large number of devices we can connect, number of provisions are less packet data loss. It is a single broadcast domain. Again, this is also single broadcast domain and but multi collision domain. Okay. Switch. Switch broadcast packet to devices, all connected devices like hub. Which initially broadcast packet to all connected devices like a hub. Okay, but later once MAC address table but later unicast packets to their destination device using MAC address table. Okay, what is this MAC address table? Unicast packets to destination using MAC address table. What is a MAC address table? It contains maps. Okay, switch port number and MAC address of connected device. Okay, so yeah, it is look like a Greek and Latin, so no harm. So I will explain. Two major functions of switch: MAC address, MAC forwarding. These parts are there. The diagram is very difficult to draw, but I will try. Okay, same diagram, guys. You have a devices. So what is this? This is our switch. Okay. I said it is very difficult to draw. So I will manipulate little bit. This is switch, don't forget. So 1, 2, 3, 4, 5, 6, 7, 8 port switch it is. Strike 8 port switches it is. That's the port numbers. Okay, we'll see how much successfully we can able to try. This is switch. Look at here, guys. These are connected like this. This is a PC connected to port number 1, for example. Right. That's I said it is difficult. Okay, this PC is connected to port number 2. Okay, and this is connected to port number 3. Okay, or maybe this is connected to port number 6. Remember 4, 5 and didn't connect, 6 only I connected. It is a 1 connected. So I will give names: PCA, PCB, PCC, PCT. So we need a MAC addresses, guys. For example, PCA MAC address is A1. Just for our understanding, A1. PCB MAC address is B1. PCC MAC address is C1. PCD MAC address is So D1. So now we are going to create a MAC address table here. Okay. First of all, this is a switch port number and MAC address, device MAC address. What will happen? So we'll see that one. A want to send a packet to B1. A want to send a packet to B. As we discussed earlier, it is A to B communication. Actually, you have to take more devices to get understand. So, okay. So what will happen? And if you have multiple colors, that is also good. No, not this one. My arrow color. It's also good. I want arrow. A send a packet to B1. So A will send a packet to switch, right? And switch will broadcast. You know that one. Switch will broadcast to everyone. So it will broadcast to everyone. To B, to C, to D also broadcast. But what will happen when it is learning? What will happen? So the port 1 is connected to A1. So in the incoming packet wise, port number 1 and MAC address is A1. Okay, it is a port number 1. The packet is, sorry, MAC address is A1. So A1 received a packet. It understands, which understand MAC addresses. It can learn what is the MAC address thing it is. So what it will, it switch automatically create a MAC address table. The port number is 1 is added to is belongs to A1 like that. Like when these devices are communicating each other, like a B send a packet to C, C send a packet to D, D send a packet to A, like that. While these packets are doing broadcasting time itself, while they are communicating each other, that time it can able to learn what is their MAC addresses mapped to their port number. So second PC is connected to C1. Okay, and third port is connected to B1. Fourth we are not using, right? So sixth one is connected to D1. So like this, it is created a packet. Example, I want to communicate now from PCC to PC D, for example, or PCB to PCD. So this is the communication I want to do it. What happened? So if you can get color of this kind of stuff, you can get it. PCB send a packet to the switch. Switch send a packet to port number 6. Then we'll receive it. Okay. So how? PCB send a packet to switch. Switch see where is the PCD Where is the PCD? What is the MAC address of PCD? D1. It will check the destination MAC address. It is a D1 and D1 is connected to 6. It will forward directly. So like that, it do unicasting. Okay, so switch initially broadcast, but later it is unicast. So that is the difference between MAC and the switch and other kind of stuff.
Hello, sir.
Now tell me.
Sir, B1 is also connected 3 and 4, but you are only considering 3.
1 second, I will go. Which
Yes, sir.
one?
B1 is
B1?
also connected. B1 is connecting to 3 or 4.
No. Can you see these ports?
Yes,
One
sir.
second, 1 second. So I see the confusion. So this is the
I also
switch, for example. This is the device. This is the wire connected to only one port only. It is a one single port. Okay. So for example, it is connected to three. That's it. Okay. It's not connected to four. Four means another wire is required like this. Okay. So why you got
okay,
a
sir. Okay.
confusion? I will tell. See, because of this wiring, the arrow mark. Okay. So I said no. This is difficult because if I have a colors, then
And
I can make it as a color like this. I can show you like this. For a communication side, I can show you like this, different colors.
yes, sir,
So
got
here
it.
is, yeah, very good. So you have a PCs. The PCs are connected to switch to different ports. Depends upon a switch. Port numbers are there, guys. For example, this is port number one, port number two, that is port number three, four, five, six, seven, eight, like that. Depends upon a switch. So one, two, three, four, five, six. So this is APC, B, C, D, E, F. It is always best to write like this and we'll copy paste. First one is A to B communication. In your MAC address, your port number and MAC address is not written. So MAC address are A1, B1 type only for our understanding. First packet sent to the switch. Switch will check the destination MAC address. If we don't have any information, what to do? We'll send a packet to everyone in the network. Like a hub, it broadcasts to packet to everyone. But in this process, switch understand A1 is so A is connected to 1. What is A1's A's MAC address is A1 and port number is 1. Like a other communication, for example, B is want to send a packet to D. B send a packet, the packet sent to everyone, not only D, also it will go to every packet. Packet go to every machine. But whenever so remaining devices will drop the packet, D accept the packet. But my switch will learn this 3 is connected to B. So based on both incoming and as well as outgoing packets. So through these ports, switch understand the port number and an IP address, sorry, MAC address. Like that it will create. So the second is connected to D, fourth is connected to E, fifth is connected to C, sixth is connected to F. Remaining ports not connected, unknown, MAC address kind of stuff. This is the MAC address table. Okay. Now MAC address table is created while communicating, but I will tell what is this unicast part. C want to send a packet to E. C want to send a packet to E. C sending a packet to up to this port. And what is the destination? E. What is E's MAC address? E1. E1 is connected to port number 4. And it will send a packet to port number 4. Then packet is go to E directly. Okay. So initially broadcast, but later it is unicast using MAC address table. Okay. Guys, this is about your switches. What is a switch? Switch is an intelligent device. Understand MAC address. MAC learning is there. It create a MAC address table while it is communicating. It is a single broadcast and multi-collision domain. We use switches in both we use in a LAN communication. Supporting is small and large networks. We can able to use it. Large number of devices we can connect by using extended star topology kind of stuff. It is a layer 2 device. It is initially broadcast the packets like a hub, but later once MAC address table is created, it do unicasting. Two major functions of switch is there. One is MAC address learning, another one is forwarding. Okay. Okay. So here it is. L3 switches also there. When you say yeah, switch is L2, but some people ask, do you know L3 switches also there? Like that. Yes. Guys, switch is L2 device, but there is a L3 switches also there. Means layer 3 switches are there. So layer 3 switches works as a switch as well as a router. The router functionality, switch functionality is also there. We use these L3 switches in generally inter VLAN routing purposes, VTP kind of communication purposes we are using. Okay. You can use L3 switches as a switch as well as a router, but mostly like it is inter VLAN routing and VTP concepts we use it. So generally switches are L3 switches. One more is there guys, that is called a switches, or two types switches. Manageable switch, non-manageable switches. In generally, we are all generally non-manageable switches means you can't configure the switch to do certain tasks to do that. It's a open switch it is. We don't do anything, just we connect and use it type only. Manageable switches will configure the switch, how to work with the switch, what port numbers, all these things we can able to manage, we can configure it. Okay, managed switches, we configure different configurations like a VLAN configurations, virtual LAN configuration, port security, port management also we can do it. Whereas a non-managed switches, just we have to connect a switch and start using. Okay, so this is our switches. Two more are there. One is router and second one is modem. Don't go to bridges. For me, router is important. Actually, I'll give break in between, but today we are already started early, but we sit early, but we started late. Okay, better complete and after break. So we're going to discuss about anything like OSL layers or IP addresses. Any of OSL layer or IP address. You know already what is an IP address, but you don't know what is IP address and all depth knowledge. But today we'll see what is the OSL layer part. Guys, router is a intelligent device. So this is a router is internetworking device. Router is a internetworking device. Okay. It works with a logical addressing. It is a internetworking device. Do not forget. It is a internetworking device, intelligent device, internetworking device. It is works with a logical addressing like a IP address. It connect two or more networks. It make a communication between two or more networks. What is internetworking? Communicate between two or more different networks. The router is a internetworking device. It is a layer 3 device. It is a layer 3 device, network layer. Guys, we call this router as a router or router. Router is a correct word because route is a word. Route means path. Router shows best path to reach the destination. Router shows best path to reach the destination. How to reach destination will tell by router only. Routers having a routing tables, using a routing tables, so then it will know how to reach the destination. Okay, using this routing table, so how to know destination. For example, guys, you're in a google.com. You open a google.com or facebook.com, youtube.com. Those servers are located in a somewhere in this world, but we are reaching the destination and you are getting information. How you know how to reach the destination? The routers in the network. Not only our router is very basic level, but in a network, there is a routers will tell the best path to reach the destination. Okay, these routing tables, using these routing tables, router will tell so how to go to the next. Okay, so these routing tables are created manually, that is called static routing. The routing tables can be created automatically using dynamic routing protocols called this kind of routing is dynamic routing. What are the dynamic routing protocols? Are IGRP, EAEG, RIP, EAGRP, OSPF, BGP kind of stuff. Okay, guys, I will give one example. So please look at here. Already I told ping command. Okay, what is ping command? Ping command will tell you can you able to reach the destination or not. It is ping command used to test communication between source and destination. So can I able to reach google.com? Yes. Okay. Trace RT. Trace RT will tell you how you reach the destination. So ping command will tell you are you able to reach the destination. Okay. Trace RT will tell you how you reach the destination. I am in office, right? From my laptop to this router 190.116.1, there I reached. Then, so I think our people are taken ACT internet service. So now ACT ISP from my PC to my router to my ISP from ISP outside there is a lot of routers. It forward into that path. So like that. So we reach one more router, then another router. Finally, we reach the destination. Okay. So this is the trace RT. Trace RT will tell you how you reach the destination. Again, I'm telling guys. Ping is a command to test are you able to reach destination or not. Okay. Trace RT is a command will tell you ping is test command to, to test whether test between source and destination is, yeah, tell me, is it to test communication, 1 second, between source and destination. Tell me, I'm here. This RT tells how you reach destination. That's it. Okay. I'm not talking all about a ping, but just know about a ping command also. Okay. So yeah, tell me you're asking some question. Okay. Guys, next one is modem, modulator, demodulator, modulator, demodulator. What is a modulator? So when you are forwarding a signal, you are sending a signal for a longer distance, you have to modulate your signal by adding a high frequency signal to it or convert into high frequency signal. So then we can able to forward it. When you are receiving it, we'll having a demodulator, so which demodulate the signal and will extract the original signal. For example, FM radio frequency modulation, normal voice signal between 20 to 20 kilohertz frequency. We add this signal, normal voice signal, we add it to a higher signal like a 104 megahertz signal, 93.8 signal, 91.3 signal, like radio Mirchi, those kind of stuff is there now. So that signals. We add a high frequency signal and we'll forward, we'll distribute the signal. So people will tune to this frequency, they will demodulate the signal, then receive a original data. So this is the modem modulator and demodulator. Okay. So normally our computers are generated a digital signal. Okay, I am connected a wire to my laptop. So the data is transmitted in the form of a small digital signal. These signals cannot be able to forward to longer distances. So what it happen? It will convert the signal into analog formats. Okay, to forward the signal through like a in our network we use TCE, UDP, twisted pair cables, UTP, STP type of connectivity. But outside it will go through telephone cables or a fiber optical cables. Sorry. The modems they make you to connect ISP. So for what purpose? Modem is will make you to connect internet. Okay. So in local network means in your LAN network. Okay. So we use UTP or STP cables to communicate. But to communicate to internet or in internet, you are communicated to internet, right? So you are going outside internet. We need modem. Sorry. So we use telephone cables or fiber optical cables. Okay, fiber optical cables, right? But communicating use. So that's why we are using modem. That is a one more point we are using. Okay, some modems, some Wi-Fi routers are routers having built-in modems. The default gateway already I told, I think so. But I want to tell one this kind of stuff, guys. I cannot design again, so that's why I'm directly copy paste. But okay, so it is small office, home office kind of stuff. If you see here, I have a devices in the network. So I have a wide devices. Look at guys, these are the different terminologies, different devices will come here. These are the devices which we are connecting through a switch or a hub. So I created a network. For example, I have a wireless devices are there. Wired devices I use hub or a switch. For example, I have a wired devices are there. So I need a wireless access point. I need a wireless access point is required, right? This is my wireless access point. So I can able to connect Right. Okay. Accessing through wireless access point. Originally it is. Wirelessly access point. This is LAN. But when you want to communicate outside of your LAN communication, okay, outside of your LAN communication, this is LAN. But what is this? This part WLAN, wireless LAN. This is LAN, wired LAN. This is wireless LAN, WLAN, wireless LAN. Okay, so to communicate outside of your network, we need a router. To communicate outside of your network, we need a router. For example, you want to access some google.com. Okay, so we have to go through first router only, whether it is wireless access point or a wired point, how it is connected, I don't mind, but we need a router. Router cannot able to send anything directly to this google.com. It need a modem to convert what are the signal you are having. So you have to need a modem. So what is this? This is wireless access point. Okay, this is the modem. This modem is through telephone wires or fiber optic cables. So it established the connectivity with ISP. So ISP make you connect to internet. Through internet you reach the google.com. Like this we are connecting. You may get a doubt, sir. I am having internet in my home. I have seen internet in my offices. I didn't see modem. I didn't see a router. I didn't see a switch. I don't see any wireless access point. Okay. So how it is possible? Because of this Wi-Fi routers act like a modem. Okay. Act like a modem. Why? Because of I will show you your so Wi-Fi routers. Okay. Anything you can open, but it is not showing its backside. Okay, very good. So if you see this picture, see it is a WAN port. This is our LAN ports, and this is the router. Okay. So WAN ports can be telephone type of connectivity or fiber optical type of connectivity. You can see this is WAN port like that. Okay. Mm, Nokia. Okay. So this is a LAN port and there is a fiber optical port is also there. So you can connect that fiber optical cable. Like the cable is connecting. You can try with YouTube also there. That is optical fiber cable also directly connecting. Yeah, here it is. So you see, this is the fiber optical cable. Okay, this is telephone, not for outside to inside. This is from router to regular telephone part. But this is for connecting outside the fiber optical cable. So modem is connected to your outside communication, that is a WAN connectivity. Okay, that is also built inside your Wi-Fi router. Your LAN ports are there. LAN ports are connected to wired devices. You know, last time I used my computer directly connected to my home Wi-Fi router. Okay, And you have a wireless devices. Wireless devices also can be connected directly because it is act like a wireless access point. And your Wi-Fi router is act like a DHCP server and DNS server also. So that many facilities are there. So this is the same diagram. And if you are combine this modem, router, wireless access points together, it is become nowadays our Wi-Fi routers. Okay. Okay, guys. So these routers also act like a default gateway, DHCP servers and DNS servers. We are using anything. Okay, take a break, guys. I'm going to start a OSA layers. We have 5 o'clock, so come back in 5:15. So 5:10. 5:10 is enough. 5:15. 5:10. Maximum 5:15. Okay. Take a break.